Hi, today we are doing Biweekly Leetcode contest 177. We'll be competing C++. Okay, let's go. Smaller pair with different frequencies. Merge close character. Some digits in a range. XY different in frequency. Choose the pair with smallest possible value of X. Oh, okay. Fardo X in A. Okay, so what does it mean? And y is not mx. Turn x and x. Is this is this what it's saying? 1 3. Okay. String S, two equal character are considered closed. Okay. The right one merge into the left, one at a time after each merge. Okay. This is what the problem is about. As we ABC YBZ YBZ. Interesting. So it seems like if merge or this already merged. Is that true? Choose index I to make it parity alternating. Okay. Is the minimum overall array parity alternating obtained by performing so it's I think it's just so when you pick a number so either don't increase Okay, how do you do this? So we go into test on this number of return 2 of them. Min. Yeah. Bound. And suppose initial delta. It's more like a pair, right? A oppose minus. Initial mn is equal to I'm going to say that if AI yeah, you have to do this, by the way. Yeah. Increase. Increase. Yeah, that's true. Now it's equal to AI minus 1, right? That's equal to now. We do this as target. Now. Yeah, if AI is equal to mn. Not really. It's equal to target, dude. Is that what the problem is? I want min. What is going on? Okay, let's read it a bit. Okay, that makes sense. That makes sense. Of this delta looks good. Okay, delta looks okay, I suppose. Oh, last. Delta is equal to last. I don't get it. Make parity alternating. Okay, let's see. Let's debug. Post delta last target. I don't know. 4, -2, -3, 1, 4. Okay. Target is -4. Last is 4 delta. Increase. Min. -2. How is that possible? How is that possible? Yeah, see this guy. Delta is 0. Last is -3. Now it's 1. delta 0 does not make sense. Last is -3. AI is 1, now is... What? So it doesn't get called? Does not get called. Closest one. Oh. It's absolute, dude. Two, 6, 1, 3. So k-digit number in a range. I want exactly k-digit. Sum of such number. Consider all possible exactly k-digits. It's weird. What? Okay, so basically you want like these to be k, and these are between L and R. So how... well, we can do something. Can we count? Because if we are here, for example, the sum will be these. Basically, yeah, that's it. basically how many times a number appear in the whole set. Okay, that's kind of hard. Okay, I'm not sure how to do this. So we give an L, R, and K, and we return. I'm not entirely sure. Yeah, so yeah. Sum of the allowed digits. So like this. So we can see that each digit appear that many times. And so we can tell something about, I don't know the answer. We can work our way up. So basically this, right? Each digit appear. There are n digits. We can choose from each. We can choose in each k position. So how about each digit? Each digit appear as n to the k minus 1 times. Because that makes sense, right? Because yeah, it makes sense. For example, you have like yeah, that makes sense because but when you choose this one, when you fix this digit, the other guy, you have an option right here and an option right here. So n to the k minus 1 makes sense now. What else? How do we count the sum of numbers? Well, that's interesting to know. Um, the total digit sum for, okay, so the total digit sum for this position is going to be the sum digits. Mm, we can, let's see, we can try like L for 1, let's go to 2. Example, then we got 11, 12, 21, 22, right? So 11 did appear 2 times. No, 1. I meant like this. This 1 appeared 2 times as n is fixed. So, okay, we confirmed that. Okay, that's interesting. So it's like 1 So 1 did appear 2 times. How about this number? This 2 did appear 2 times as well. So what I can see is 1 plus 2. 2 times something. I'll tell you that much. So we can combine, basically. We can combine them together. Can they combinable? Yes, they can. But then then I think something is missing. The last piece, I think what I'm missing is the last piece of this thing. How do I ship them over there? They are repeated. Um, it sounds like it's 10 to the K, but like the number 10 to the K something. I'm not sure, but like it sounds like it's like this. Am I right? Because it's 1, then it's 10, then it's 100, then it's 1,000, so it makes sense. Okay, let's just try that. EFFT. We're going to time something. n power k. No, it's not k. It's k minus 1. U times n. Is that true? No, you're not going to times n. You times Sn, then you times mint of 10 dot pow k. Is that true? $600, 4,000. I mean, it's close. It's very close. This thing over 9? Is that k plus 1? 666? What's going on? Six six looks it looks good. Oh, okay. That's easy, I guess. Okay, I can go over the contest now. Okay, that last Q4 was horrendous. The code was short, but I can tell you it's not that easy. So the first one is consider distinct XY. They have different frequency, so what we can do is we can go over the array, take whatever frequency we got, yeah, and kind of do like I did. I had a horrible time debugging this. I didn't really observe the constraints, but my code is and log in, obviously. It's very easy. You just track the min and the max. For Q2. Q2 is you just do what it said. You while loop until it ran out of the merge. Yes, that's it. Q3. Q3 is a bit interesting. I got a hard time debugging because I forgot the absolute value. It was so obvious overall. So basically you have this kind of, no, not open, new. So you have this kind of array, right? I'm drawing a graph to represent the values. What you want to do is find the minimum to make them alternating. In terms of parity, what does that mean is either you start with an odd number, then even, then odd, then even, then an odd, then even, or you start with a even, an odd, even, odd, even, odd. Right? So you just try these two, how do I say? You just try these two starting parity, and you just take the min of it, and over, and it has the extra thing. It has the extra thing of among all the minimum way to make it, you want to minimize the maximum, this peak and this peak. Minimize the maximum minus minimum values and return it. Yeah, so it looks pretty complicated, but there's a very big, I would say, observation in terms of these kind of pattern is you look for the extreme. You modify the extreme and everything will work out. What I mean by that is you would try to either the minimum or the maximum, you would try negative 1, 0, and 1. So after you got these three, you just take them in. And yeah, that's just it about the question. Very easy, right? But I think it's very hard to come to that conclusion if you're not experienced. Yeah, so what I did really is just just find the position of the min, then we do this guy. Okay, what this f function is doing is take the target from this position, this minimum extreme, basically. So I go backward and try to alternating it. And every time I see that it is not aligned with the parity. For example, I see a, okay, let's see. If the minimum is 1 and there's a 1 next to it, what I would do is I would try to increase this to 2 instead of going back to 0. I would try to going to this way because I fixed this as the minimum already, so I don't want anything to go below that. And if you notice something about this is you won't modify this as more than one. You won't modify a position more than one. That's what it actually say about this. Yeah, so we just do this. If it is equal to less than or equal, there are the case that it is less than. For example, you pick a position of one, but there are two number one in it. So when you try this option of increasing it by one, this will become two, and this will become one, right? But it doesn't really matter. So when it is less than or equal to the minimum, you just increase it by one. When it is greater than the minimum, you do this. You negative one, and you just track the maximum and minimum. You go two paths, obviously, and you just return the number. Yeah, that's it. That's it to this question. Pretty interesting one, not gonna lie. Okay, for Q4. Q4 is interesting. You have an L, R, and a K, and you can use any digits that is less than or equal to L and less than or equal to R, and you have to form it K digits. How this work? Um, I kind of went over this when I was solving it to explain my thought process. So the code is short. I'll tell you that much. So when you look at this position, when you fix a digit, for example, you fix it to be 1, every other digit has the contribution of, okay, let's, n is equal to r minus l plus 1. Every other digit have n options, right? So, okay, let's do 2 for like better. So the total sum will be 2 times n to the k minus 1 for this position only. But you have an account for the shift of it to the whole number, which is 1 right here, 10 right here, 100 right here, 1000 right here. So when you so it meant okay, so what I'm trying to say is when you pick a digit 2, how many time will it contribute to the whole to okay, how many time does it contribute to the whole sum? So you pick a 2, so you pick a 2 here, you pick a 2 here, you pick a 2 here, pick a 2 here, pick a 2 here. So you will have 2 times n to the k minus 1 as um as every digit 2 will contribute this much, but you have an account for the shift of it in terms of 1, 10, right? And that's basically is you times 1 right here, and you plus 2 times n to the k minus 1. Basically, this whole thing repeatedly again, and you times 10. And then you plus again, you plug this thing in again, you do 100. So basically, when you do this, you have this number 11111 k times, k times. And that's a beautiful fact about this. So overall, you can come to the formula that 2 times, no, digits times n to the k minus 1 times 10 to the k minus 1 over 9. Okay, this part is kind of confusing, but you can figure it out if you just draw it out on the paper, piece of paper. Um, yeah, and that's just for one digit, right? How about 3, 4, 5? So that's easy. You just do L plus 1 up to R, and you plug it in right here as sum, and you do this, and that is technically the formula. Pretty okay. It's pretty interesting, but I wouldn't say it easy. I don't know how. Okay, maybe I'm not good at math because it took me a while. But thank you for watching, and see you next time.